Hello, everyone. Welcome to my presentation for my LLP project. So the project is an LLM agent that I created, a large language model agent that I created that is trained on the Code-19 dataset. The Code-19 dataset is a collection of different research papers on COVID-19. So I created this LLM agent based on that was trained on the dataset of research papers, and I fine-tuned it to specifically answer queries that are related to COVID-19 and smoking, or COVID-19 and high blood pressure. So I divided my Python script into different sections, and yeah, where at the end I create a simple web interface that users can interact with, hence interacting with the model. So I'll begin with section A, which is mainly just setup and dependencies. So to save time, let me just, let me restart the session. Let me set the runtime. And to save time, let me just run all. So I begin by performing all the setups and the dependencies that the project will require. Okay, section B is about data acquisition and initial loading. So generally, it's just acquiring the data. So we use the cargo dataset download to get the metadata of the Core-19 dataset. And then we load the metadata into Pandas data frame. And then, yeah, we call .head as well as .info just to understand the structure of the dataset. So as you can see here, these are the different columns. And as you can see here, these are the non-null objects that are found in each column, where you can see the code UID, there are about 16,070 non-null objects. Section C is about data cleaning and preparation. So real world data is rarely clean. So here we focus on the specific description column, which contains abstracts and summaries of the papers that are involved. So we ensure that the rows do not have are non-null, and also we ensure that the description column is treated as a string over here. It's very important to do this because the quality of the AI's knowledge base depends on clean and usable input data. And yeah, that's all about section C. We move on to section D. Section D is content-based document filtering. So as I explained earlier when I was beginning this presentation, I fine-tuned this AI agent to only answer queries related to COVID-19 and smoking, but also COVID-19 and high blood pressure. So to do this, I have to filter like only the research papers that talk about these specific things like COVID-19 and smoking, but also COVID-19 and high blood pressure. And I did this by implementing keyword filtering. So we define a list of keywords for smoking and high blood pressure. The specific keywords I use for smoking are like smoking, cigarettes, nicotine, tobacco, and vaping. The keywords I use for high blood pressure is high blood pressure, hypertension, and BP. So what really happens here is that the descriptions are searched, and if any of these keywords are found, then that paper is considered relevant for the AI agent and will be used to train the agent. So I found 346 relevant documents that talk about smoking and high blood pressure in the COVID-19 dataset, which has COVID-19 research papers. So section E is about embedding and model initialization. So to make the text understandable by our AI, we need to convert it to numerical representations called embeddings. These embeddings capture the semantic meaning of the text. So we are using the Hugging Face embedding class with this specific code. And yeah, it's popular and an effective model for generating text embeddings. Okay, section F is about vector database using the Llama index function library. So this is the core of our agent's knowledge. First, we change the filtered pandas data frame rows into Llama index document. Each document will primarily contain the text from the description column, the paper's abstract and summary, which also add the paper title as metadata to each document. This can be useful for citing sources or understanding the context of each paper. So yeah, this index stores the embeddings of our documents and allows for efficient similarity searches. So when a query is performed, um, the agent compares the query with the information that is found in the vector database. And the vector database is created here in section F using the Llama index function library. We move on to section G, which is language model LLM initialization. So this is like the brain of our agent. It's where queries are processed and compared to documents in the vector database, in the vector database using the Llama index function library. So when a query is given by a user, it's compared to different papers already stored in the function library. And it's this section G that makes all of that possible. Yeah, so section H, chat engine configuration. This brings together our vector index, which is the knowledge base, and the LLM to create an interactive conversational agent. Yeah, so this initializes the functioning of all the other parts previously spoken about and now brings our agent to life. So apart from that, I also made a simple web application in Flask, but also with a bit of HTML and JavaScript for the front end for section J. So yeah, without further ado, okay. So without further ado, let us have a look at our chat agent. So I just created a simple collab URL that initializes all of these HTML, CSS, and JavaScript in the front end, and also like uses the agent as the backend. So here it is. Hello, ask me about COVID-19 in relation to smoking or high blood pressure. Okay, so let's write a simple query. Hello, what is the relationship between COVID-19 and high blood? And okay, let's start with smoking and smoking. Oh, this is the response. Unfortunately, there is no evidence to suggest that smoking directly causes COVID-19 or increases the risk of severe COVID-19. However, smoking is known to increase the severity and mortality rate of COVID-19. Smoking is associated with a weakened immune system, which can make it harder for the body to fight off the SARS-CoV-2 virus. The virus can use the smoke's chemicals to cause inflammation and damage to the lungs. Yeah. So this is the response, and the agent got this from the COVID-19 dataset from the relevant research papers that we got. Let's try something else. Okay. Hello, what is the relationship between COVID-19 and oh, high BP? So there is evidence to suggest that there is a positive relationship between high blood pressure and COVID-19. Research has shown that people with pre-existing high blood pressure may be more likely to have severe COVID-19, particularly if they also have comorbidities such as diabetes, kidney disease, or liver disease. And yeah, you can read the rest of the response. So yeah, this is it. And just a quick summary. So this is my LLM agent trained on the COVID-19 dataset, specifically to answer queries about COVID-19 in relation to smoking and COVID-19 in relation to high blood pressures, in relation to high blood pressure. So I divided my Python script into different sections, and I divided the whole project into different sections. So section A is set up in dependencies, where I download all the dependencies that are needed. Section C is data cleaning and preparation. So I prepare the data, remove null objects, and from section A, I noticed that the description column mostly contains more information about each research paper. So I decided to filter based on the description column. And yeah, so I got 14,126 documents after cleaning. And then I got content-based document filtering. So, okay, from these documents, which one talk about COVID-19 and smoking and COVID-19 and high blood pressure? I got 346 documents. Then I embedded the model. Section E, embedding model initialization. And then section F, I created a vector database using the Llama index function library. And section G, I initialized the LLM. And section H, configured the chat engine and generally revamped and started the agent. Section I is a web application where the chat agent is the backend and section J is the front end. So after doing this, I got a collab URL, and upon clicking the collab URL, this is the front end that I designed, and you can interact with it through this chat. Thank you very much. This is the end of my presentation. Thank you for giving me your time.